All right, folks, if I sound a little bit fun, it's because this is my third time trying to do this video, and I have committed a little bit of time and a couple of words, which is why I had to continue to redo it. Okay, so this one's going to work. Everything's going to work in this one. Put that good mojo out there. So, maximum and minimum. When we were talking about radicals in the last two lessons, the place that you've seen a radical before is in our quadratic formula. When you use this in grade 10, you're just like, oh my gosh, that looks ridiculous. I'm just going to b squared minus 4ac. I'm just going to look at it on the formula sheet and hope that I know what goes where. Okay, but there's a radical hiding in here. And our radical work is kind of priming us for some of our concepts that deal with both your roots of equations and their maximum and minimum values. So it's a nice segue into this stuff. Okay, we are looking for our vertex. Max or min is your vertex. It's got two possibilities. If we have a happy graph, you've got a minimum value. And then if you've got a sad graph, you've got a maximum value. Okay. So we want to know whether or not the function has a maximum or minimum, and then we have to sketch it based on key identifying features. So in order to be able to do this, you have to know the different equations for quadratics. There are three of them: standard form, factored form, and vertex form. We've got, this is an example of factored form, and this is an example of vertex form. And, well, you could argue that it's also an example of standard form, but standard form only tells us a direction of opening and a y-intercept. If you have vertex form and you have factored form, you can get a lot more information about the graphs. So from factored form, the first thing we can state are our zeros. So our zeros are the values that if you were to plug them into the equation, into either of the brackets, they would cause the bracket to go to 0. So what value if you put in for x, if we put in a positive 1, the whole bracket will go to 0. And then here, if we put in a positive 5, we would have a bracket that would go to 0. So let's plot those points. 1 and 5. This is where everything fell apart in the second attempt at the videos. Just so you know, not bitter. Okay. Now, the next important piece of information about the vertex is that it happens in between your two 0 values, your two x-intercepts. So what do I mean? I mean that we can just by looking at this, we know that the vertex is going to fall somewhere on this red line. Now, we don't know if it's going to be up here. We don't know if it's going to be down here. We don't know if it's going to be there. Like, we have to find that out, but we know that it's going to fall somewhere on that line because parabolas are symmetric. Okay, they're symmetric around their axis of symmetry. That's why it's called the axis of symmetry. So just by looking at this, we can say we know that that happens when x is 3, but we have to be able to show that mathematically as well. So the way you do that is you take your two numbers for your zeros and you average them out. What do you mean? Well, there's a 0 at 1 and there's a 0 at 5. So we do something called your axis of symmetry. Axis of symmetry. I short form that later because I don't want to write it out all of the time. And we take our two zeros and we add them together. So 1 plus 5. We're going to divide that by 2. 1 plus 5, 6 divided by 2. That gives us 3. So we know that when x is 3, we are going to find our vertex somewhere. The way to find out where that happens is by taking this x value and substituting it back into the original equation. Sub x equals 3 into y. So we would get y equals 3 minus 1, 3 minus 5. 2, -2, -4. So our vertex happens when the x value is 3. Therefore, vertex at x value of 3, y value of -4. So then we would go down here and we would go, let's try it again. You can do it. Just the nice words, just the good ones. Okay, 3, -4. And then we would join our quadratic. Oh, yay. Okay, that was a good, attempt at a makeup. Oh, yeah, bud. We're taking a picture of that one, kids. Okay, so, thank God this is recording. It'd be just my luck for it not to be recording. Let's look at a different way we can get the information about, oh, am I done? Am I done? Does the quadratic function have a max or min? This one has a minimum. We didn't answer the question, but now we did. Minimum. Okay. So with this graph up here, we've got a vertex form. You could say it's standard form, but I would think of this as like negative a x minus h squared plus k. That's how I'm thinking of it. And that so it's negative, which means it's a sad graph. It doesn't have this, which means that happens at 0. And then it has a +5 at the end. So our vertex here happens at 0, 5, and it's a sad graph. Like that's what I get from that equation. You could say it's a vertical reflection through the x-axis and it's a vertical translation up 5 units. Like we know what this looks like. So 1, 2, 5 over 1 down 1 over 2 down 4 4. I don't 1, 2, 3, 4. Okay. Oh, that one got away from me. And that one just didn't even show up. Okay. So those are two ways we can figure out if we've got a max or a min. In this case, we've got a max. Nice. Come on back. The maximum or minimum value of a quadratic function occurs at the vertex. If the graph opens up, the function will have a up, up. If it opens up, it has a minimum. I have a feeling there's a thing. And if the graph opens down, the function will have a maximum. Okay.